Here's a quick warm-up, just covering these two problems really quick, referencing the point-slope form that was talked about on day 1. And if I were to actually put this transformation into this form, the fact that it is reflected in the x-axis means that the slope would need to be negative. The fact that it is compressed vertically by a scale factor of 2/5, that 2/5 is actually going to be my slope, so y equals negative 2/5 times, since it is going to the right 4 units, that's a positive direction because you go to the right when x is positive. So x minus 4 is what will go in parentheses here. And then since it's going up 3 units, that's a positive direction, so plus y1 plus 3. So I would know that a point on the graph is 4, 3, and the slope is negative 2/5. Moving on to number 2, this is the parent function that we're dealing with today. So y equals x squared, that's going to be our parent function today. And that's the reason why I'm having you start out by graphing this. For y equals x squared, just using a table of values, and I'll set that out to the side. If I have an x value of negative 3, if I square negative 3, I get positive 9. Again, that's just by using the function. Squaring negative 3 gives me a positive 9. Now if I square negative 2, I get a positive 4. Square negative 1, I get a 1. Square 0, I get a 0. Now we're going to see a mirror image here that when you square 1, you get 1. So that was related to negative 1. When you square 2, you get 4. And when you square 3, you get positive 9. So you will see this mirror image happening here. There's symmetry in this graph. So I'm going to go ahead and plot those points and graph it out. And this is a parabola, is what shape this makes. If you're in class on this day, we will actually do a paper folding activity where we actually define the different parts of a parabola. But if you're not, don't worry, you don't really need that. And you can ask me to catch you up on that at some point. But here's my parabola. In this case, the axis of symmetry would be the y-axis. The x equals 0 is my axis of symmetry. This is just extra information. And 0, 0 is the vertex. All right, let's go ahead and get going into our examples. Today we are going to be using vertex form, and that is y equals a times x minus h squared plus k. This is related to the point slope form we were doing yesterday, where x subscript 1 is now h, y subscript 1 is now k, and instead of a slope you have a dilation factor, which is a. H comma k is the vertex of the parabola, meaning on the previous parent function the vertex had been 0, 0, so if it moves left, right, up, or down, it's moving to this point h comma k. And x equals h will always be your axis of symmetry, and a determines the shape of the parabola and the direction in which it opens. So let's go ahead and take a look at this first problem. X minus 2 squared minus 3, I'm going to go ahead and graph that, and I'm not going to use a table, I'm actually going to transform it from the parent function. So first thing is, the value of h here is positive 2 because you change your sign on the x value. So I know that my vertex is positive 2, and negative 3 is the value of y for my vertex, so 2, negative 3. I can go ahead and graph that out here. So there's my vertex. Now, here's an important thing. A equals 1 here. So it's actually going to be the same graph as my parent function, y equals x squared, just shifted to the right 2 units and down 3 units. So now, let's go to where the vertex is. And let's go to the right 1 unit. And what you got to think to yourself is, I traveled to the right 1. what is the square of 1? And that would be 1. So go up 1 unit. So I end up at the point 3, negative 2. And that's another point on my graph. Now let's go back to the vertex. Let's go to the left 1 unit. What's negative 1 squared? Positive 1. This point on my parent graph is related to 1, 1. This one's related to negative 1, 1. They've just been shifted to from 1, 1, they've been shifted to the right 2 units and down 3 units to become this point. Each point undergoes this transformation right here. Now, let's go back to my vertex and let's go out 2 units. And 2 squared is 4. So I'm going to go up 4. 1, 2. And there we are at 4, 0. And when I go to the left 2 units of the vertex, negative 2 squared is also positive 4. So there it is. And then if I go to the left or right 3 units, I'll be going up 9, which would put me at 5, 6. And negative 1, 6. And here's my graph. Do your best on trying to make a parabola when you're graphing. I'm going to be kind of forgiving because obviously I struggle as well. And there's my graph. Alright, now things to consider. On my parent function, which was y equals x squared, the value of a was 1. Here, the value of a is also positive 1. So here's a couple things that are not happening. This graph is not reflecting in the x-axis, nor is it getting stretched or compressed vertically because the a values were the same. Now, what is happening to it? It is not the same graph as our parent function y equals x squared. It is different, and how it changed was it went to the right 2 units and down 3 units. So I'm going to say that now. And this is to describe the transformation. So translated, right 2 units and down 3 units. And we are finished with example 1. Alright, here's example 2. Going through the same process for this one. Here, there will be a dilation, and we'll cover that in just a moment. Alright, let's go ahead and find our vertex first of all. Plus 3 is with x, so the value of h is negative 3. Remember that you have to change your sign there. So the vertex is going to be negative 3, comma, positive 4. That one you leave alone with the sign. So negative 3, 4 is my vertex. Go ahead and graph that out. Now, key things to notice. First of all, because of the negative in front, when the a value is negative, this function is going to be opening downward. Secondly, it is getting stretched by a scale factor of 2, and you'll see how that works right now. So, let's go to my vertex and let's go to the right 1 unit. 1 squared is 1, but because this is getting multiplied by negative 2, let's multiply it by negative 2. It's not going to go up 1 unit, it's actually going to go down 2 units. Because 1 times negative 2 is negative 2. So this is a factor of negative 2, this was an a factor of 1. So I end up at negative 2, 2. And I'll erase this nonsense through here. And so I have another point. Now, let's go to the left 1 unit. Negative 1 squared is positive 1, but we're not going to go up 1. Because of the negative 2 multiplying it, we're going to go down 2 units to right there. So, negative 4, 2. And we'll keep on graphing points. Let's go back to the vertex and go to the right 2 units. 2 squared is 4. But multiply that by negative 2, I'm actually going to go down 8 units to negative 1, negative 4. And let's go to the left 2 units from my vertex. Negative 2 squared is 4, but I'm going to multiply that by -2, and I go down 8 units yet again. And there I am at -5, -4. And you could go out 3 units if you like. I'm actually going to stop there because it's actually going to end up off my graph, so I'm not going to worry about those. There we are. This is our graph. So a few things have happened here. It's been translated. 3 units left. And up 4 units. Excuse the bell there, they're dismissing for lunch while I'm making this video. Another thing, it's been reflected in the x-axis because the slope was negative. Well, not slope, the a value was negative. It's opening downward now. And lastly, it got vertically stretched because it's greater than 1 by a factor of 2. Remember how we were multiplying everything by 2. And there's our description of the transformation from the parent function. Here's our last graphing one of this lesson. I'm going to go ahead and start by figuring out the vertex, and that one's going to be kind of tricky. People get thrown off by this one a little bit. There is not a number with the x value. Well, there is. It's like it was x minus 0 squared. So we're going to call that vertex 0, comma, -5. So I know it's going to get translated down 5 units. So 0, -5. Now I'm going to apply my a value. So let's go to the vertex and go to the right 1 unit. 1 squared is 1, but because of the 1/2, I'm only going to go up 1/2 of a unit. So I'm going to be at the point 1, -4.5. And if I go to the left one, I'll be at -4.5 as well. Now let's move to the right 2 units from the vertex. 2 squared is 4, but because of the 1/2, half of 4 is 2. So 2, -3, and -2, -3. And I can go on to doing 3 units out. 3 squared is 9, but I'm not going to go up by 9 units. That'd be too far. Multiply that by half, I'm only going to go up by 4.5 units. So I'm going to be at 3, -0.5, and -3, -0.5. And here's my graph. Okay, we already talked about the vertex, so let's mention the translation. It translated 5 units down. And then the second thing that happened is it did not reflect. It's still opening up just like y = x squared does. But it did get compressed vertically because it was a number less than 1. By a factor of 1/2. And we're done with this problem. So on examples 4 and 5, I'm going to show you a graph of a parabola, and then we're going to write the function. First thing I'm going to do is identify the vertex here, which is -1, 2. Second thing I'm going to do is determine what the value of A is. So when you're at the vertex, when you go to the left or right 1 unit, how far down is it going? It's going down 1, 2, 3 units. So that's actually going to be an A value of -3. Now I'm ready for my answer. Y equals. I know that it's Y equals because they used Y in the graph. It would be f of x if they had put f of x there. So y equals a times x minus h squared plus k. I was just rewriting the vertex form. Now I'm just going to insert my items. Negative 3 times x minus negative 1. I'm actually going to write that as x plus 1 squared plus 2. And I'm done with the problem. Alright, doing the same process again for this problem. First of all, the vertex is at 2, negative 3. That'll be my h and k. My a value, let's go ahead and go to that vertex. Let's go to the right one. It looks like it's going up a half, but I'm not for sure. So let's try a different one. Let's go to the right 2 units. 2 squared is 4, but instead of going up 4 units, it's only going up 2 units. So it is, in fact, an a value of positive 1/2. I know it's positive because the graph is opening upward. Now I'm ready to drop it into vertex form. So y equals a 1/2 times x minus 2 squared minus 3. Because it's plus negative 3, I'm just going to write that as minus 3. And there's my answer. And that's our day. Look on my website for the assignment. Thank you.